Hello, welcome to Fun Project Monday. The show, the live stream where we design a very nice product, something electronically nice, live, and simply having fun. No deadlines, no nothing. We simply sit one time a week here, maybe future more often, and design something nice. And it's prime time. It's prime time everywhere watching you right now. It's 4 o'clock in the morning at my place. And it's even prime time for you if you're watching it on replay. Why not? Prime time. I have some coffee that makes me happy. And yeah, let's go. Let's revise what we did the last time and see what's up. So, that works. So, last time we did some designing at the front panel. We did shit here. We need to change that, of course. That's not good. That's not good at all. Of course, you switch LEDs low side. You don't do it high side. Obvious. We have designed as a last thing that. I need to change it a little bit. So, yeah, Now my audio works. So I talked all of that for nothing, but I don't care. I simply continue further. So, okay, that's... did it stop working in between? I don't know, because I checked it before I started. I don't care. So yes, we want to use 595 as a shift register. Yeah. So let's give us a 595. Because one thing we can always do is build a parallel circuit which we will connect with a 0-ohm resistor, or decide to not populate. That's always an option. Of course, I made my search very... Oh yeah, 74HC. 595. At this point, it doesn't really matter what part we use. I certainly want to use a part which is not such a pain in the ass as solder. The Solix are okay. Oh, what kind of manufacturer is that? Do we have them? Oh, I know that I have a shift register from Xperia in my library that I can use. That's of course a little bit better. A 74HC. Oh yeah, that's great. Oh, and it's directly build up, so we don't have so much to think about. That's great. So, yeah, we'll simply connect them like that. Should be good. So, a shift register for everybody not thinking about is a device which has a shift register built in, quite obviously. And what you can do is you can serially print a bit stream, so you can convert a serial signal to a parallel signal. So we won't need to use X thousand lines on a connector to connect two PCBs together, which is something. Of course you can't. No, we won't do this. We won't do this. One problem with those shift registers I will show you is that they are all not able to transfer high amounts of current. If we change the screen, can we change the screen? Of course you can change the screen. Let's go to let's go to Mauser and check the stock there. On the cheeky. And let's take 74 HG 595. I have especially a Philips part inside my library because it was the cheapest. Or did it had some sort of... Or was it a part that had... some sort of higher current. I don't know anymore. I put this specific part in for a reason. It should be this one. And if we take a look on the maximum ratings, limiting values here. If the supply current is maximum is only 70 milliamperes. For LED, that's not really so. It's not really enough. So we will need to use some sort of amplifier, and we could use we simply could use a few transistors, but soldering few transistors can be bothering, so we can also use ULN. I think we need that one, a ULN part that are Darlington transistor arrays, so we can simply drive there aren't ULN parts. What? Let's try it here. Was it UNL? I'm pretty sure there were ULN parts. What? Okay, now I'm buffed. Do I have it open? I did some checking before off screen, so I don't tell so much shit. Yeah, off screen I searched for an part which maybe has more has a higher power rating, but the shift register are most times built for higher speed than higher power. So of course that's not an option. But now I'm of course we don't want those. Yeah, ULN. Oh, maybe we're not happy with 701. Okay, let's take the data sheet. So they are definitely available. Oh, nope. I hate that. One nice thing, of course, we're able to, you can use them to drive anything because they have the protection diodes built in. So you can drive LED arrays, and can drive relays. That's one nice thing. In most cases, I would certainly use such a part to not be bothered to solder everything, to solder a few transistors. But that's an option. So, well, first we already have our JLC basic parts in there. Let's check V2 and 7000. How much current does it? How much current capability does it have? Because if it has a current capability more than 20 or 30 milliamperes, I'm happy with using it. Oh, it doesn't matter, we can take datasheet of one. They are almost the same. But the ballpark, yeah, 200 milliamperes. That's of course great. Can check that with an SMD part. SO223 of course. And that one will also have, yeah, plenty of so we'll simply use the basic parts and drive them with the and drive them directly with the oh, that's a 2 and 7002. That's of course something different. Let's check that. Yeah, still plenty of current capability. So we will certainly be able to use those. Don't know if that's the exact one here. But ultimately I don't care so much. So that should be correct. Yeah. Why that? Oh, we will place them like... That's of course the wrong way around. Yep, that's correct. And we add some more of those. We'll flip them. Oh, now it has. Yep, now it's great. So. Well, wait a minute. Yeah, one thing about not using the GPIOs of the Raspberry Pi directly. Why did I dump this? That doesn't make sense. Of course. Oh my god. Let's go. Thank you. So that does make sense. Yeah. Having the gate on the side of the diodes doesn't make sense at all. So let's put it directly on and hide where it is connected in one row. So. Like that. Make it nice later. Of course, you need to, now we need to connect everything. Oh my god. Did it bug? It bugged. So let's put them directly on one row to make the circuit somewhat smaller. So it looks nice. So a problem with using the Raspberry Pi GPIOs directly is that they are, or the Pico's GPIOs directly, is that they are 3.3 volts. And of course you can cost optimize using only the needed we need GPIOs. But at the first glance, I would imagine that the GPIOs wouldn't be able to drive all these LEDs, because you have a problem that a few of them can be on at the same time, about 4 to 5. Like those two definitely every time. Yeah, 4 to 5 that are 40 milliamperes. Can the Raspberry Pi drive that even? We should find that out. 2040 datasheet. Check that directly. Bus fabric. Legal disclaimers. Package. No. Frequency, power, no. Power consumption. No. Electrical characteristics. So. Solar profile. Thank you. They did a very nice. They did a very nice datasheet. And we have a lot of very realistic examples. That's very nice too. Don't they have some? Let's try to find it like that. Match case. Ah, here. Okay, that's the core voltage. Of course. Okay, core voltage supplier. Oh yeah, E limit 450 milliamperes. No, that's only the core, isn't it? Output current. Gate clocks. Let's go back to current limit. Okay, the question is, was everything the free? Currently, I'm not sure if it's only talking about the core voltage, DC power supply, digital I/O power supply, pin specifications. Yeah. Oh wait, we have a separate I/O voltage. Okay. I'm not that familiar with this chip anymore, so I'm learning on the fly. What can the highest I/O VDD be? Okay, the IO voltage is only allowed to be 3.3 volts. Okay. Okay, some of our current sourced by GPIO and serial interface pins are 50 milliamperes. That's of course not very much. That's not really much. So we definitely need some sort of driver. So my assumption was correct. So those here. So we will need to add here. It's not. Let's go down a little bit. And we have that one. Okay. And connect all of those to ground. Put that down. And put those inside. And those. That of course doesn't know, that didn't look good. That's not readable, so I will change that one. Put that one down again. Connect those two. Connect those straight to. Okay. And connect a few grounds to have a. Yeah. Let's get a ground, because this ground is way much faster. So I take that one. Because having some sort of crosslink in that area would make it more unreadable. And we want to have this circuit as readable as possible. Putting that little bit up is okay. So we can add another ground. Oh. I'll put this ground, although it's not variable here. Because otherwise I would cross that gate line and that would be not very nice too. So now we connect all the gates. Like that. Like that. Now it gets a little bit funky. But fortunately it's still really obvious what's done here. So I'm okay with that. The Q7 S-pin on that logic, I think that this logic part was not that standard, I thought. I think there was something special with that one. So the last two, we're going to use these as an going to use these as the high side switch for the buttons. So with every LED update, we can have a small we can have a serial event on serial communication every 25 milliseconds or every 50 milliseconds, and after the communication, check the buttons. So that's completely okay. So that's high side button. High side one. Oh well, no, that's with that one. No, we don't want to do this with that part. No, we certainly don't want to do that. No. In the end, we can. One thing I thought was very unfortunate that we use second IC just to. Oh no, that wasn't good practice. We'll need to delete that. Of course, we could add a high side switch with the we could add another high side switch with the Xperia part. The problem would be maybe we could have 3.3 volts. Yes, that's not a problem. Yeah, it most probably would be on 3.3 volts. But that doesn't make a difference. So, and do we have a depletion mode MOSFET here? Do we have a depletion mode MOSFET? I once checked for one. Because with depletion mode N-channel MOSFETs we have no problem. We will have no problem switching the high side part. So let me check if I can find the no screws, bolts. No, you shouldn't see this here. Yeah. Okay, for that, we most probably use an separate part. So the switches will be most probably driven by the Raspberry Pi itself. So that will be VNet. So let's change VNet. Oh, switch matrix size set. Oh yeah, I already done that. Good. And then we can use one of these not use buttons. For the use one of these buttons for the For that switch. Well, it's a little bit nicer if you put it in like delete line. We will connect it directly under here. Add to net high side 2. Yeah, connect without wire. And that one, so we can put that part somewhere else. And that wire will get its own part. Yeah. So we connect all of these together. So put those up here. So we can think about adding some more LEDs later. I think that could have some help, or we will dodge one of those LEDs. That's also an option. Okay. Then this one will be yeah, we certainly will need to add a connector on this. Oh yeah, we still need to find a connector. That's very annoying, but necessary. Good. This can be directly connected to 3 volts of a resistor. Yes. Because we only need some debouncing. One very nice thing I found is that the Pico has a toggleable Schmidt trigger that should make the debouncing very easy, so we don't have to bother doing it in software. I will add in 1 resistor and 1 capacitor. Okay. Yep, I will need to turn off these. Which... So great, now it's turned off. It won't bother me anymore. Okay. So definitely 10k resistors up here, or some resistors. So we want to have 2 resistors that go up here. Want to do an we want to connect this side. So that will go to some sort of connector. Then this side, yeah, that will get resistors. So these will both switch to ground. So we'll simply connect them here. So that will go to ground. That here is connected to ground too. Okay. And then we have on both sides 4 resistors. Yep. Put them on one height. Then we'll have some resistors and a capacitor. To connect those to an IC, and then we are happy. Because we need to make sure that we don't. Oh no, we won't increase. We won't exceed the maximum ground current for the I/O pins with those buttons. That's not happening. And with a capacitor, and then we're happy. A non-polarized cap. So let's put it like that. Connect those to ground. Yep. Put those to ground. And then we have we need another one. No, don't. So like this. Oh no. What window do we get? We get the layout editor. Okay. So connect those. And that can go to ground too. That ground here. We'll put it up a little bit so it gets so it's more in the middle. And we'll add this button here too. we'll give it a name. So this will be switch matrix row 3, and we'll connect this one directly to switch matrix row 3. Hello. Internet row 3. Connect without via great. Now we can add the VNOP down here. Two resistors, two caps. Cap non-polarized. Two please. And that goes directly to VCC. Check symbols. Plus 5 volts. Actually, we want to have that at 3.3 volts. Yeah, that should be definitely on 3.3 volts. And this will be naturally at 3.3 volts too. And those two will be at 3, yeah. So all the switches need to be at 3.3 volts so we don't go into the region of damaging our Pi. And besides a connector, that should be it. That should be the whole front panel. Nothing more. Let's look for a front panel. How many pins will we need? We will need 5 volts, 3.3 volts. Oh, yeah, we can add that here. We should add those here. Those can be added down here. Put them a little bit apart. And that is the that in. Shift register power supply. No, no, no. Here. And let that. Okay, I need to check what the pins were. Especially what OE and MR were. So let's check the datasheet. It was an Xperia part we wanted to check. good enough. Yep, it is this part. Pinning information. Yep. Serial data output. Oh yeah, now I know why I've decided like that, because I could directly connect it this way. Master reset. We probably won't need an reset. Clock input, yes. So, clock needs to be connected. Storage register clock input. Let's check it down here. So, okay. Yes, that's data. DCP data. Okay, some part away that I last work with those. Shift through for the content. SHCP. So I probably need that one too. Add some more space, and I want to have first this form and then no, I don't want to delete this. First of all, go into 2 and then into 3. So OE and MR are some kind of reset. So with OE we can simply turn off everything. That's of course so I will first go here. SHCP. That's 1 clock. STCP. DS. That goes to the Pi. Up. So that's output enable. So we need to pull that down. Actually, we could put this to we could bring this to a Raspberry Pi and have a lights off switch, which is implemented directly. Could do that. We most probably want to do that, because if we want to put all the lights off, we simply say, no problem, we will very simply shift zeros into the, we will simply shift zeros into the register. That's completely doable. So we don't need to complicate that. Will we need a master reset? No, because we will simply put in your data. Who cares? That's okay. Wait a minute. So storage. Inputs. Why do you have a storage register? I don't get it currently. So the shift, of course, the shift data is okay. Wait a minute. So if shift register clock input, yeah, that makes sense. And we have the storage. Okay, we need the storage to shift it through. Okay, good. That makes sense. So we can have the shift register clock the whole time, but only with the storage clock it will be, the data will be put through. Okay, that makes sense. Okay, we will not use the master reset. I don't see any reason to do this. The master reset should be pulled up, if I understand it correctly. Master reset. Active flow. Yeah, it needs to be pulled up. So there are 3.3 volts. Yeah, 3.3. Good. That's need to be pulled up. That's the deal. And actually, we wouldn't need that one, because we're not planning to switch it. And if we're not planning to switch it, we wouldn't need an. We definitely wouldn't need a resistor at this point. Yeah. Okay. And for beauty reasons, I will put that down here. So, what's Q7? Oh yeah, that's the data shift for, okay. And we'll put that here. Ah, wrong. And I didn't change it here. That's unfortunately. So that will be the shift register circuit. Call it like that. Okay, then we need some sort of connector. effectively we need 1, 2, 3, 4, 5, 6, 7, 8, 9. Did I count it with 1? Wait a minute. So we need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15 connectors. So 16-pin connector. Even using a shift register. That's of course... it was a good idea to use the shift register. Okay. Let's go again and search for 16-pin connectors on LCSC and see what we can get. Most probably some Molex part. Or some Molex or JST connector. We tried it last time and wasn't very very successful. We do it another time. So we want to have an I don't want to use an FCC connector. I want to use an PCB IC sockets. I find it very unfortunate that they don't have an image search like Mauser, so you can simply simply go through images until you see what fits, and then you automatically have the right category. That's great, but that looks JST Sales America. Okay, let's do this. JST Sales America. That's plenty to choose from, I'm happy. Okay, apply. There. Now we have a point where I want to filter for numbers. But I can filter for pitch, 2mm pitch. I don't know. I have no idea what's standard in that case. So yeah. Although, wait a minute, 2.5 is standard, yes. So 2.5mm pitch. And let's take a look on that here. On the data sheet, so we can find the right part numbering and directly search for the right part. Be of course the best way. So we have some colors. That's not interesting. Circuit 16 here. B16BXHA. That should be good enough. Yeah. Of course, we have some others. What's that part? Nope. Not going to use this one. So that's definitely something we could use. Let's check out this part, because this part is an SMD part, so something which is also a good idea to use. Oh, and we have the... So let's check this. If we can get this with 16 connectors. Oh, they even give the part numbers for the... Oh no, they don't really do this. How much power can we... 1 ampere is more than enough, yes. Okay. So we simply change the number to 16. Could be an option. Okay, very low on stock. That's not really good. So yes, we could use those. Do I have stock? Oh yeah, they have stock. Good. Boom processor electronics. So, what's the connector for that one? Let's do a Google search. Or the plug for that one. Yeah, okay, we get this JST connect. We must have that. So let's go back to this boom connector. Boomele. Let's simply buy that only for the name. Boomele connectors. I have a Boomele connector on my... So... Our problem is we have a lot of connectors. So that should be card edge connectors. Unfortunately, I can't find an... Oh, they're also doing the JST style. Oh, they have SMD parts directly. Okay, that's of course very nice. But not with 16 pins. Nope. So, let's see that we get the right connector for that one. Because that looks like inside that is that a break? Oh my god. Yeah, so I'm not able to find a datasheet. Or in datasheet. Do I get... No. No chance. So, do I get an... do we get directly a part number for the connectors that go in there? That would be... Oh, they also have an SMD. but only with 6 pins. Through hole shrouded. Oh, that these XHP 16 should be the pin. Oh, great. Let's check that one. Oh, that looks great. What part number has the contact? Contact is an... okay, there are 2 shapes. And there are... okay, now I need to know this kind of shape I need to use. Circuit. Also you have 2 connector shapes and you need to get the right one. And I'm not sure which one I need to get. Housing. Okay, here is not specified what kind of shape I need. Okay. No chance. Okay, let's check for another connector, because I can't look through that. I want to buy, and I am not much interested in buying stuff without knowing what I will get. Let's check for Molex connectors. We want to have wired board, wired wire. Should be the right category. Oh no, I can even check that 16 pins. Because they are, oh my god, they're expensive. Let's check another company. They are really expensive. I don't want to give out so much money for connectors. Yeah. That's Molex. It's JSD. Nope. Other USB connectors. Okay, I will need to do some research on these A and B shaped contacts off screen. I will do this on screen, but most probably we'll use some sort of... we'll use that contact that is very unfortunately not available as... is it really not available as an SMB part? through hole. Housing through hole. No, only have 6. Maybe I have another connector series. Can also be the case. So wire to board. Yeah, we have so many connectors. Of course, we will have. They will need to have one that fits our. So I want to have one row. Don't care what kind of series that is. And SMD with some sort of small pitch. Not straight. And okay, 6 remaining, that's actually a good, yes. It's not a pin you want to use. That's a through hole part. Or is it? I can't see it on the picture. See a bigger picture. That's a through hole part, yes. That's a through hole part, through hole. Good use of that. Do I have more stock incoming? Question is. Because having a connector which is placed on the bottom side of the board is okay too. Actually, that is. Yeah, I need to check that off screen. I don't want to do this on screen anymore. So yeah, but now that is mostly finished and should be okay. All the calculations, I think I will do in one stream and go through all LEDs. Go through those differential equations. No, they're not that bad, but it's a small differential equation. And then we will specify the power circuit and check if we done everything here correctly. Ah, please don't say I did that the wrong way again. I'll check that again. Okay, so then goodbye.